session on discrete manufacturing. It's one of the few in this particular forum, but we always try to introduce some element of discrete manufacturing in a kind of a heavily process-oriented session. But there's a lot to learn from the discrete that can be applied in the process world as well. So, good afternoon. My name is Sal Spada, and I'm one of the ARC analysts that cover the discrete manufacturing industry. I've been with ARC for over 20 years, covering machinery, production processes, and equipment used in discrete manufacturing plants. So today I have a great lineup of companies, one company and two organizations that represent a lot of what is going on in the discrete manufacturing world. And one of our first speakers is going to be Nezvat Ertran? Yeah. Nezvat Ertran. He's the chief architect and senior manager of Sandvik Corporation. The next speaker is going to be, after that, will be Dean Bartels. He's the director of the John Olson Advanced Manufacturing Center at the University of New Hampshire. And the third speaker is Mr. Thomas McDermott, and he's the executive director of DMDII, which stands for the Digital Manufacturing Design Institute. Innovation. So, with that, I'm going to just start off with a little introduction on terms of what this session is about, what we're going to be talking about, and try to, hopefully, we can all kind of beat off of each other. And one thing I would like to do a little bit differently than it's happening in the other sessions is let's make this a little bit more interactive. While the speakers are talking, myself included, don't hesitate to ask any questions. Otherwise, if you do want to wait for the end of the session, you're welcome to write your questions down on paper. But I'll warn you in advance, we'll be taking questions. Some of the talks will be extended a little bit longer to address this situation, so please don't hesitate to interrupt. So, just a little bit of the background I wanted to give on the whole discrete manufacturing evolution. And I've been following this for so many years, and I look at this particular slide, and I look at the digital divide that occurred, over the last 20 or 30 years, and it's started to close up. Everybody now is talking about digital transformation, digital connectivity, and things of that nature, but I look at this, and we had a period of time when there was a huge digital divide between the design and the planning and the execution side of the manufacturing plants. So now what we're looking at is more disruption coming out with the IoT, industrial IoT, in terms of more data being collected, more equipment being connected, and creating new types of business models that will be able to flourish under this type of scenario. And of course, some of the great examples of this, these platforms, examples of certainly in the commercial world, you're looking at companies like Uber or Facebook and that type of ecosystem that has flourished. And in the manufacturing world, we envision the same type of scenario. So what we're looking at, too, is the idea, this evolution of machinery becoming more intelligent, more software-defined, and kind of going through a progression of not only being intelligent and connected, but starting to become more an integral part of the data feed for systems like PLM, product lifecycle management. Well, in the discrete manufacturing world, you think about, production planning, product design, and all of this information going back into that world to improve upon the designs. In addition to that, we'll be looking at other services being applied by the machine builders for asset management and predictive maintenance, monitoring the health of the equipment and improving some of the operational aspects of the manufacturing world. And we'll hear a lot of that actually from our speaker from Sandvik. So a lot of the additional revenue streams which companies talk about how business transformation will take place is many of the machine builders and other service providers will provide remote monitoring services, these predictive maintenance services, and like I said, operational improvements, and something I call software-defined machines. And the concept of software-defined machines is, you can think of one of the better examples is, Tesla. and the vehicles driving on the road, they collect data from the machines continuously. They start to analyze that, and then they redeploy software based on the behaviors of how their machines are being used. We envision this type of behavior will also be employed in the manufacturing sector to improve the capabilities of machines that are already installed in your plants. And then the last item is closed-loop design. Closed-loop design means we're taking some of the operational effects, operational behaviors, closing the loop with the machine designers, and designing better machines. And so we look at this as a closed-loop behavior. And so this whole idea of closing the loop with the machine in the field, the designers in the plant, in the machine builder's house, and then start to deploy new types of software deployments called, in some cases, called live engineering. So, and that will be transformative. The other aspect of discrete manufacturing, we always think about machines just simply sensor-based and reacting based on their sensory environment. So we look at this, sense, analyze, and act kind of cycle within a machine, whether it's a robot, mechanical press, or metal fabrication. But with more and more data being collected, more and more analytics being applied, more people talk about cognitive intelligence, we start to think of another loop surrounding all of this traditional, sense, analyze, and act loop, but also machines will begin to understand their environment, do more interpretation, be more perceptual, and be able to act somewhat independently of what their original program was. And with that, I leave you our speakers. Nesvat Bertrand, Tom McDermott, and Dean Bartels will be here for your questions. Please don't hesitate to ask. Nesvat, please.